Yes. So now here we are going to learn how to derive the formula for elliptic curve addition that we just saw in the previous video. So I believe that deriving when necessary, okay, is more important than simply just memorizing the formula, because it enriches one's understanding, okay, and it improves the high level thinking which is necessary to innovate or learn new concepts, right? Memorization is something like a brick wall, okay? So the ability to derive is, even though it is slow, right, it's like a flowing liquid which can adapt to, let's say, the new conditions or the new rocky terrain or a easy path or whatever. It is like kind of like flexible. Let's start with the cases, right? So now there are like different cases. Of course, addition with infinity is rather easy to handle. You are going to encode infinity in certain way in your code, right? And you just detect for it, and it's going to give the same number because the point of infinity is an identity element. But we are interested in this like special cases of a plus b, where x1 is not equal to x2. Okay, so a is x1 comma y1 and b is x2 comma y2. All right. If x1 is equal to x2, then the third point, the a plus b, is a point at infinity. Okay, it's like very easy to handle. Now, in this case, so what we will do, I'm not going to show you the diagrams here. Okay, you can open a your own GeoGebra instance, or you can just take a paper and pencil and draw the curves and the lines if you like. But with respect to derivation, okay, we need to find the equation of the line. So that will be the step 1. Okay, the equation of the line connecting A to B. So here we have two distinct points. So you can use the 2-point formula, which you probably have learned in your high school or in early college days. Okay, so you're going to find this line, equation of the line. So you will get the equation of the line in this form, right? Y is equal to some, I'm going to use the variable yes, because since you are a Bitcoiner, you would have likely read about programming Bitcoin book. So that the variable used for to represent slope is yes. Some s times x plus, what is it? Let me just call it as yum. Okay, some constant, some offset. So you can derive an equation of this particular form. Slope is very easy to like find in this case. It's simply y2 minus y1 divided by x2 minus x1. Right? I think m will be some other point based on how you choose x1 and y1. Right? Whatever. So now you have this equation. And step 2. Now we are trying to find the formula for the third point, right? So the third point which intersects, the line that intersects with. Once we find the third point, we simply have to like negate the y value to get the reflection on the x-axis. So that part is like pretty straightforward. So finding the third point of the intersection of the line in the curve is the difficult part. But we already have the equation of the curve as y square is equal to x cube plus 7. And you just plug in the value here. So you will get something like sx plus m the whole square is equal to x cube plus 7. Okay, so it's a cubic equation. The cubic equation can have like at most 3 roots. 3 roots is then 3 possible values of x that actually satisfies this equation. Right? And we already know the 2 roots. I mean, we are assuming that this points x, this points a and b are known to us. Okay, so we are assuming that these points a and b are known to us. So you already know these 2 x values, which is x1 and x2. And you simply have to find the third x value, I mean x3. You can try to like substitute the values of x1 and x2 and try solve the problem, but that is like not very easy. But since we already know that these 3 are the roots, we can be confident that x minus x1 into x minus x2 times x minus x3 equals to 0. So now we have these 2 equations. You can expand this equation 2 and you can rearrange equation 1 and you can compare the coefficients one by one. So when you do that, you will end up with an explicit formula for the point x3. So once you have x3, you can solve it for y as well by plugging it in this equation. Okay, because y square, plus square, like there are some complications with it. Okay, so the third point, you see, I mean, from comparing equation 1 and 2, you can deduce a form of x3. So you can find x3 will be a function of x1 because we are assuming x1 is known, x2, and we also know the slope yes, right? So it will be some form of it. You can just rearrange it, and you can just substitute in this equation y. I mean, in this equation of the line, you will get the point for y. You will get the formula for y3 as well. There is another interesting case where a is equal to a. Basically, you are trying to double the point a plus a. In this case, what you do, you take the equation of the curve, find the derivative. Okay, so 2y times y dash. I'm not going to explain how derivatives work here, okay? You can just, the best way, if you have forgotten how all these basic maths work, it's always best to learn them. And one of the best possible ways is going to the website brilliant.org. It's a paid website. But you will be like, if you have interest, right, you're a good Bitcoiner, you want to learn about this cryptography. There are so many changes which are pushed by the devs. If you have to actually really verify whether the changes are necessary, right? And you can't just simply trust them, right? So you need to improve your understanding of how the code and math all this works. So of course you need to take that step. Okay, but this is how we will find the derivative, and we can say that the y dash is equal to 3x squared divided by 2 times y, and all these operations, square division, everything is happening on modular arithmetic over some prime. Okay, don't forget that. This is not like simple real number division or addition is going on. That's not what's going on here. So this s dash, this is actually called the slope. Okay, you already have the point for a, okay, which is x1 comma y1. You already know this point, and you're trying to find the a plus b. Plug in the value of x1 and y1, you will get the s. So once you get the s, you can find the tangent to the line. Sorry, tangent to the point at a to the curve, right? So that will be of the form y is equal to sx plus some constant. You should be able to solve this as well. So similarly, we have this, and once again plug in. If you find we found the equation of the line, again plug in, do the step 2, right? Expand the coefficient. So now in this case, x2 is also x1. That is the only difference. The 2 points are the same. Okay, we have x minus x1. So step 2, in that place we have x minus x1 the whole square multiplied by x minus x3 is equal to 0. So this will be one equation, and another equation, this will be the same, right? This equation 1. So you just compare the coefficients, and you will get the formula for x3. Apply it here, you will get the formula for y3. Right? So this is how it works. So if you are stuck at any point, you can always go back to the Programming Bitcoin book, chapter 2, where these steps are laid out for you. Right? And yeah, I hope this helps you in better understanding the elliptic curve cryptography used in Bitcoin.